Hello everyone, welcome to Pace Digital. This is Charita Dittakavi from Pace Hyderabad. And now today we are going to discuss multinomial applications from the chapter Permutations and Combinations. See, there are many different formulae engaged in this multinomial applications like n plus 1 or r plus 1 or r minus 2 or n minus 2. All this just rule out and just follow one process that will be enough for the whole applications of the multinomial applications types of problems, wherein how to identify such type of problems, that is whenever we are dealing with identical elements, right? Suppose here, try to understand, I am collecting some four pebbles from one shop. Okay, so I went to a shop, so I need to get some pebbles. So I have different color pebbles, right? I need to pick any four pebbles, any four color pebbles is what I need to choose. And how many do I need? Suppose I need some 10 pebbles. My question is, get some 10 pebbles, right? It can be any colors. It's like blue. See, you have blue, yellow, and white and green. These are the colors what I am giving you. And remember, identical pebbles only. All these pebbles to be identical. These are of a same color. These are of different colors, but yes, they are of same shape and same size. If at all they are such way. Now I have blue, yellow, white, and green. Now, in how many possibilities can I bring these pebbles? I want total number to be 10 pebbles. So try to understand now. Now let me take, I will choose some 2 blue, okay, 3 yellow, 4 white. So obviously 1 should be green, isn't it? Or I will not select blue at all. It is like I need not select anyone from blue also. I will select 6 from yellow, 3 from white, and 1 from green, but still I can make a 10. So which means I am not at all selecting any of the blue color there, right? Or I can select all 10 from the blue only. I need not select any of the other colors. It also still makes 10, right? So, or I can select 3 blue and 5 yellow and 1 and 1. That still makes a 10, right? So it is like you pick up, my question is, you pick up any number of balls or any number of pebbles is what you can collect of any of these colors, of these four colors given to you, such that I need only 10 pebbles, right? So different combinations is what you will be getting, right? So how to identify or how to notate this is what we are going to learn now, right? So what does this mean is, suppose if I have C1, C2, C3 and C4 colors is what I have, right? So my x to the power denotes the power, or the exponent denotes the number of pebbles what I am choosing, right? So here it will be x to the power 2, let it be. Here I have x to the power 3, here I have x to the power 4 and x to the power 1. Make my x to the power 10, right? In the next case, my x power 0, my x power 6, my x power 3 and my x power 1 make my x power 10. Altogether these many, okay? So what does the power indicate here? The power indicates the number of pebbles or number of items what you are choosing here, right? Now here I can write it like x to the power 10, x to the power 0, x to the power 0, x to the power 0. All together I make my x to the power 10. Even here x power 3, x power 5, x power 1 and x power 1, all of these make my x to the power 10. Right. So now tell me, as I said, you can pick up any number of balls is what I said, right? So you can pick up any number of pebbles from the color 1. So how am I going to represent that? Now observe very carefully now. It can be 0 pebbles from the first color. See, color 1, color 2, color 3 and color 4. In general, I am writing it can be 0 pebbles from the first color, or 1 pebble from the first color, or 2 pebbles or 3 pebbles. It so on continues there, isn't it? Or let me write it here below so that it will be more clear for you. Right, this is color 1, color 2, color 3 and color 4, right? Okay, so my color 1, I can select either nothing from the color 1, that is x power 0, or 1 from the color 1, that is x to the power 1, or 1 or 2 or 3 or so on. It can be any. Same is the case with my color 2. I can select I can select none, which means I'm not selecting any of my color 2. Or indicates operation is plus there, right? Or 1 from the color 2, or 2 from the color, or 3 from the third color, so on. Remember, the power indicates the number of pebbles or the number of items what you are choosing for your application there. Now here, C3 again, x power 0 plus x power 1 plus so on, all these. And C4 also x to the power 0 plus x to the power 1 plus x to the power 2 plus so on, all these, right? Understood? Now all these put together is my x to the power 10, right? Understood? Or let me consider some r balls is what I'm just, or pebbles is what I'm just taking there, right? And now, did you understand till here? Everyone understood till here, right? Right. Now, the next one, what do I observe from here? See, observe each and every bracket what I have written here is, all these are in GP or not? Right? So they are all in GP, right? X power 0, x power 1, x power 2, x power 3. All this is sum of an infinite GP. I said you can select as many number of pebbles as possible. The general form is what I'm trying to write now, right? So as many pebbles as possible is what you can pick up from each and every color. That is a choice given to you there, right? So when the infinite GP sum, that is what your sum of infinite GP is A by 1 minus R is your formula, right? So your A, that is x power 0, 1 by 1 minus R. R is same as your x, right? Whole to the power, how much? See, the same value is repeated. I have taken 4 such colors, so I will take it to the power 4. So can I write the same as 1 minus x whole to the power minus 4 there? Right? 1 minus x whole to the power minus 4. Now, how do I write this? What is the expansion of this using binomial expansion? So, do you remember that? Binomial expansion, right? So, before going for that, now observe here, how many such cases did I write earlier? This is case 1, case 2, case 3 and case 4. I have written 4 such cases. My answer is, see, I got these many kinds, right? So what is my answer? Is it like when I add them up, do I get 4 into x power 10? Right? So I got 4 such combinations. Like that, if the whole day you are left in that shop to get so many combinations, as many combinations as possible, right? So obviously you will be getting some 3 or 10 or some 15 or some 20 or some 200 such combinations or some 3000 such combinations you can be able to pick, right? So is it same as treating some k times your x to the power 10, or it is just the coefficient of x to the power 10 in your expansion there, right? Is this point clear? Right. Now when I'm talking about this expansion, how do I expand this? So using my binomial expansion, remember one thing, it's a quick recap of your binomial expansion. Whenever you have negative to the power negative here, when you've got the same sign, obviously you will be getting all positives. Whether it is 1 minus x to the power minus 4 or it is 1 plus x to the power 4, you will be getting each and every term to be positives. If you have a change of sign here, 1 plus with a minus power or 1 minus with a positive power, then you will have alternate positives and negatives there. Now, how are you going to start with your expansion? Whenever you have such a value, your expansion will be 1 plus 4c1x plus, just keep reducing this and then solve. Oh, not about reducing, it's all about increasing, right? The sequence will be increasing there. That is your 4c1x is done. Next will be your 5c2. Increase your 4 and c by 1 and rewrite here. So that is your 5c2 x square plus, next comes your 6c3 x cube plus, next comes your, just a minute, yeah, I hope it is visible to you. Right. So plus here you go with 7c4 x to the power 4 plus so on it continues, right? Now what do I want actually? My question answer is I want coefficient of x to the power 10. That is my answer. When you observe the pattern here, observe the logical pattern which is going on here. See, x to the power 4 has got a c4. X to the power 3 has got a C3. X to the power 2 has got a C2. So, my coefficient of x to the power 10 will be having C10 definitely. Understood that point first? C10 is a definite there. Along with that, when you have a power 4, you got a 7. Power 3, you got a 6 here. Power 2, you got a 5 here. Power 1, you got a 4 here. Do you understand that? Power 4, 7. Power 3, 6. Is it just you are adding by 3? Right? So when I want x to the power 10 expansion, obviously I need to have a plus 3 there, which is 13c10, which is same as writing 13c3 also, because NCR is basically NCN minus R, right? Either you write it 13c10 or 13c3, absolutely fine, right? Now, how to get the general rule out of these statements? Now, how many color pebbles is what I have taken? 4 pebbles or 4 colors is what I took. 4 colors I took and I want 10 pebbles. Okay. From which I got 13c3. So what is the rule that I followed? And see, always I want a 10 as my answer. My RHS is my 10. That is my R. Okay, na? So I will represent it like n plus r minus 1 CR. Try to understand your R is 10. Fine. That is your RHS. That is your 10 pebbles is what you need to get there, right? 10 pebbles is what you need to get, right? Next, n plus r minus 1. What is your n and what is your r? R is anyhow, I just told you 10. What is R? R is how many colors you have chosen. 4 colors is what you have chosen. I mean, say R is your, sorry, R is your RHS, that is 10 is what you want. N is the number of color balls you have chosen, or number of pebbles is what you have chosen. That is how much? N is 4. So now observe 10 plus 4 minus 1, 13. Exactly sets your answer there, right? So finally what I can conclude is, if at all you want 4 such combinations, 4 such combinations and you want 10 values there. Just a minute. You have 4 combinations to check it. Just a minute. Now it is not writing. Let me erase this. So finally, from all this is all the derivation of what we have done. So selecting, finally what I can conclude is, if at all I have to select some 10 things from any number of 4 different such colors, that means if at all I have to select R things from any number of such n different combinations or n different colors, my answer will be n plus R minus 1 CR. Just remember this. This includes the case of rejection also. 0 also will be included. You are not selecting any of one of the colors. Absolutely fine. No issue at all, right? So this includes the 0 combination also. So do not exclude that from your values. So your n plus r minus 1 CR is the formula what we have derived for the multinomial applications. Right now we are going to go with multinomial applications. Some 10 or 15 problems is what I'll be going with. Fatafat, we will be solving each and every question so that you will understand the application of this formula in a better way, right? Right. Now question is, select number of ways of selecting 15 balls from an unlimited number of 6 different colored balls. Okay. So how many do I have to select? I need to select 15. So my RHS is 15. So your R is 15, right? How many number of colored balls combinations is what I got? My N equal to 6. R equal to 15. Now what should be my answer? N plus R minus 1 CR. That is my answer, right? So just apply that, you will get your answer. That is your 6 plus 15 minus 1 C 15. So what is your answer now? 14 plus, yeah, 6 plus 21 minus 120, right? So that is 20C15, which is same as writing 20C5, right? What is 20C5? 20, you reduce it 5 times. 20, 19, 18, 17, 16 upon 5 factorial. 5, 4, 3, 2, 1. 5 4 is 20, 20 got cancelled. This is 6 times and this is 3 times. That is how you got your answer. Just multiply that and you will get your answer, right? So this is number of ways of selecting 15 balls from an unlimited number of balls. 6 different colored balls are given to you. So your N is 6, R is 15. Just apply in your multinomial theorem. N plus R minus 1, CR, right? Now going for the next question. Now, the question is a plus b plus c plus d equal to 20 given to you. Find the positive integral solutions for the above equation. See, it's like my a plus b plus c plus d. I have 4 things. I can put anything there like 2 plus 3 plus 5 plus whatever it is. 15 will be equal to 20. How many such combinations is what I have? Earlier, the same concept is what we have done, but there is a slight change. Earlier, I can select nothing from A, right? Nothing from the color one also I can select, but here it isn't like that. The question is regarding positive integral solutions. Positive in the sense, does 0 come into that case? 0 will not be coming into the positive case, isn't it? 0 is neither positive nor negative. I can never consider a 0 there. Got the point there? So I need to give at least 1 to each and everything. I cannot say that I am not selecting anything from any of these 4, right? So I should mandatory select at least 1 from each. That means 1, 1, 1, 1. And I should give, first of all, 4 things to be given there. That means I am left with only 16. So now my question has turned out to a plus b plus c plus d equal to 16. This is my new question framed because I need to calculate the positive integral solutions only possible there, right? I cannot say that I'm not selecting A or I'm not selecting B or C or D. So I need to select at least 1 from each and every kind there. Hence, give 1 for each. That is 1 plus 1 plus 1 plus 1. 4 is already given. So when 4 is already given, now your total count reduces to 16 only, right? So now your R is standing for your RHS. Remember your right hand side, okay? Remember that way. So now your R equal to 16. N equal to 4, apply the formula N plus R minus 1 CR, you get your answer. So N plus R, this is 16 plus 4, 20, 20 minus 1, that is your 19 C 16, or you can write it to be 19 C 19 minus 16, that is 3, which is reduce 19 3 times. 19 into 18 into 17 upon 3 into 2 into 1, you calculate, you get your answer there. Right. Now the next question is based on the same second question. There is a slightly different pattern what we have observed here. A plus B plus C plus D equal to 20, and they said all the entries to be odd only. I want each and every element A, B, C, D, all these to be odd is what I want, and odd notation is what? 2 alpha plus 1. See, I am reframing my question. I am given A plus B plus C plus D equal to 20, but how do I reframe it? A is my 2 alpha plus 1, B is my 2 beta plus 1, C is 2 gamma plus 1, and D is 2 delta plus 1 equal to 20. This is how I reframed my question, because they said each and every entry what I am going to place in my A, B, C, D should be odd only. Right? So all this A, B, C, D to be odd numbers only. Odd number notation is 2n plus 1 notation. 2 times n value is even. Even plus 1 is your odd there. Right? Now, what is your answer? 2 alpha, 2 beta, 2 gamma, 2 delta. Just take a 2 common. You are getting alpha plus beta plus gamma plus delta plus 1 plus 1 plus 1 plus 1. 4 equal to 20. Now, what is your alpha plus beta plus gamma plus delta, which is 20 minus 4, that is 16. 16 upon 2, which is 8. Right here, now your RHS is 8. That means your R is 8, N is your 4. Now you apply R plus N or N plus R minus 1. N plus R minus 1 CR is what you can apply. So 4 plus 8, that is 12. 12 minus 1, that is 11 C8, or it is same as writing 11 C3, because 11 minus 8, that is 3, which is reduce your 11 3 times. 11, 10 and 9 upon 3 into 2 into 1 is what you can get. Okay, understood that? Right. Next question. Right. Now, the next question is like you have a number of ways of selecting a dozen mangoes from three different go downs. So, you have three go downs, go down 1, go down 2, go down 3. How many you are supposed to select? You are supposed to collect few mangoes. So many mangoes is what you have to collect, such that their count is how much? A dozen, right? So, obviously, the dozen count is what you need to frame there. So, your R is 12. N is what? You have got three different go downs. So that is N is your 3. Next, your final answer will be the same. N plus R minus 1 CR. That is 12 plus 3, 15 minus 1, 14 C12, which is same as writing 14 C2, which is reduce 14 2 times. That is 14 times 13 upon 2 into 1 will be your final answer there. Right? Now coming for the next question, number of ways of distributing 16 identical coins to 4 boys. So we are distributing how many? Number of ways of distributing 16 identical coins to 4 boys, when any boy may get any number of coins. It is like any boy may get any number of coins. It's again the same multinomial theorem applicability what we can do here, isn't it? Right. Now, my answer for this will be what? 16 identical coins are there distributed to 4 boys. Right. I want altogether total 16 coins. Distributed to how many boys? 4 boys. So, obviously, your N equal to 4, R equal to 16. Clear? Right. So, your formula is N plus R minus 1 CR. Right. So, final answer 16 plus 4, 20, 20 minus 1, 19C 16, or which is same as writing 19C3, which is 19, 18, 17 by 3, 2, 1. You get your final answer there. Right? Now going for the next question. Every boy gets at least one coin. So think about it. Every boy gets at least one coin. So every boy should have at least one coin in his pocket, right? So we have how many now? We have 16. In that, if I am giving, how many boys we have? We have 4 boys there, right? So altogether we have 4 boys, and for each and every boy, I am giving one coin to one boy, right? So now out of 16 coins, I have already filled their pockets with one coin each. So 16 minus 4. Now how many coins do I have to distribute? 12 coins. So altogether 12 coins I have to distribute. That is to how many boys? A plus B plus C plus D. Right? 4 boys I have to distribute 12 coins. Is this my reframed question now? Right? Because I have already given away one coin to each and every boy, because every boy should at least have one coin is what they said. That will not be in my count now. Clear? I am left with only 12 coins because I have already given 4 coins to each and every boy there. Right? Now, my R is 12. N is 4. Again, apply N plus R minus 1 CR. So, 12 plus 4, which is 16 minus 1, that is 15 CR, which is 12, which is same as writing 15 C3, right? 15 C3 is what? 15, you reduce it 3 times. 15, 14, 13 upon 3, 2, 1, right? Finish. So now next question. See, all these cases is what I am discussing in the same question. What is my question? Number of ways of distributing 16 identical coins to 4 boys. Remember that. Okay. Now, I have 4 boys. Every boy gets at least 2 coins. Earlier, I have given just 1 coin. Now, 4 boys are there. I have to give 2 coins each. So, 4 into 2, 8 coins are done. Right? So, 8 coins I have already given away. Now, in between A plus B plus C plus D, I have to distribute how many coins? 8 coins, because altogether 16, out of which I have given already 8 coins away, right? So 16 minus 8, 8 is what I have a count now. Now what is my R? R is 8, N is 4. Now apply N plus R minus 1 CR formula, you'll get your answer. That is 8 plus 4, 12, 12 minus 1, that is 11 CR, that is 8, or it is same as writing 11C3, right? Now the next question is what? Every boy gets at least 3 coins now. Now we have 4 boys. Each boy should get at least 3. So 4 into 3 coins is what I have already given. 12 coins is what I have already given from the total 16 coins, right? So 16 coins, 12 were already given. So my A plus B plus C plus D. Now my distribution factor among all these 4, how many I have to still more distribute? I have 16, out of which 4 threes, 12 coins are already given. 16 minus 12, which is 4, right? That is the count what I have to distribute. Now here my R is 4, N is also 4, right? Now my answer will be N plus R minus 1 CR again. So that is 4 plus 4, 8, 8 minus 1, that is 7, 7C4, or that is my 7C3 is my answer for that case. Understood? That is my fourth question done, right? So here we are going to distribute, like we are going to discuss almost some 10 types of problems which are very, very important. All these questions, all of different kind, each and every question will be killed using the same rule, that is multinomial theorem, right? Right. Now for this question. So we have to give number of ways of assigning 30 marks to 8 questions. So I have 8 questions. I have to assign 30 marks. For the first question, it's like, let me take question 1, Q1, Q2, Q3, so on till Q8. The sum of all these should be equal to how much? It should be equal to 30. This is my question, right? So I can, it's like I can assign any number of marks for any of the questions there. I can assign 1 mark for first question, 3 marks for the second question, 2 marks for the third question. It is my choice, right? So it's again the same multinomial rule what I can apply here, right? So my RHS or right hand side is 30, which I will consider R to be 30. N is how much? How many questions I have to distribute that to? 8 questions. So N is 8. Apply multinomial N plus R minus 1 CR, which is 30 plus 8, which is 38 minus 1, that is 37 CR, that is 30. So which is same as writing 37 C7, because NCR is NCN minus R. Now coming for the next question, assign 30 marks to the, in the same, it's the same question in a different way. Right, assign 30 marks for 8 questions with a minimum of 2 marks for each. Again, is the same like earlier question. We have to distribute 30 marks to 8 questions, like question 1 plus question 2 plus so on till question 8. Now 30 marks with 2 marks at least for each question. I have 8 questions. 2 marks I have to give to each and every question. How much now? 8 questions, 2 marks each. That is 8 into 2, 16 marks done. 16 marks I have already distributed. Now my reframing the question will be what? 30 marks, out of which 16 marks are already assigned. So 30 minus 16 I have already assigned. So 14 marks is still what I have to distribute in my choice. It is my wish. It is like I can give Q1 as nothing else there, Q2 with 3 marks. It is my choice, right? Now your N equal to 8. R equal to 14, apply N plus R minus 1 CR, which is 14 plus 8, which is 22 minus 1, that is 21 CR, that is 14. Or you can also write it like 21 C, I think it is 7, right? Yeah. Now the next question. Yeah. Right. Now, this is a different kind of question. That is non-negative integral solutions. When they said non-negative, does 0 come into the case or not? Think. Non-negative. 0 is neither negative nor positive. Yes, non-negative in the sense 0 also will be coming under my case, right? So now I am given non-negative integral solutions of a plus b plus c plus d plus e equal to 15, right? My total sum to be equal to 15. And they have given another condition stating a plus b plus c is 5, right? Now a plus b plus c is 5 if I place it here, right? Tell me, what do I get? Reframe your question. A plus b plus c is 5. So 5 plus d plus e is 15, which means d plus e is 15 minus 5, that is 10. This is one condition to be satisfied. Along with a plus b plus c is 5, the other condition also to be satisfied. Both the conditions to be satisfied. Answer from here and answer from there is what you find out, and then multiply them. That's it. Here your n equal to 3, r equal to 5. Here your n equal to 2, r equal to 10. Remember, always r is your RHS, right? Now apply n plus r minus 1 CR. Apply here. N plus r. 8 plus n plus r is 8 minus 1. That is 7C5 from here times here 10 plus 2, 12. 12 minus 1, that is 11C10. You can write it to be 7C2 times 10C1. This will be your answer there, right? Now this question. Now we want non-negative integral solutions of a plus b plus c plus 5d equal to 15, right? So such questions we have never come across, isn't it? A plus b plus c plus 5d I never come across. Let me write it. A plus b plus c is equals to 15 minus 5d. Let me think about it. Okay. Now use the same approach. This is your r. So r equal to your 15 minus 5d. N is your 3. Apply the formula n plus r minus 1 CR. What do we get? Let us check. So n plus r minus 1, n is 3 plus r 15 minus 5d minus 1 CR. What is r? R is 15 minus 5d. Now what do I get? 18, 18 minus 1, 17 minus 5d C 15 minus 5d. NCR is same as writing NC n minus r, right? So I'll reframe this as 17 minus 5dc, subtraction of these two. 17 minus 15, NC n minus r is what I'm doing. So 17 minus 15, how much is it? That is 2, I guess, right? And minus 5d minus of minus 5d plus 5d gets cancelled. Now this is my answer. Now I don't know what are the limits for d. What can be the d taking, right? So think about it. How can d take the values? See, 5d, minimum to minimum. Suppose if 5d is 0, it can max to max. What can d take? I have to frame only 15. I need to get only 15. Maximum value that d can take so that I get a 15. Maximum value for d. See, these three can be zeros. Maximum value for d. 5 into 3 only 15, right? So, max to max, my d can be taking 3. So, your d can be values of, it can be 0, it can be 1, 2 or 3. So, what are the values that d can be holding? Right. So now my answer will be substitute d equal to 0, 1, 2, 3. Either d can be 0 or in the sense addition, right? Either d can be 0 or d can be 1 or d can be 2 or d can be 3. Now suppose either, if at all your d is 0, what do you get? That is, apply in this 17 minus 5d, 17c2 or in the sense addition. Next, d equal to 1. Substitute d equal to 1 here. 17 minus 5, which is how much? 12c2. Or apply 2 in d. So 17 minus 10, which is 7c2. Or apply 3. 5 3 is 15. That is 17 minus 15. That is your 2c2. Now your answer will be sum of all these, right? That you calculate. I am not doing for now, right? So whenever you have such values, you just transform that to the other side and think about it carefully. What is your r? Apply n plus 1 CR only. Apply the same formula. Think about what can be the values of d. Because your final answer, you got it in terms of D. What can be the values of D? D max to max, you can go till 3. That's it. It cannot go beyond that. If you are going beyond that 3, D equal to 4, if you are substituting 5 into 4, 20 is what you are getting. But you just need 15 in sum of all these 4. Right? So hence your maximum value of D is 3. So starting from 0 onwards, isn't it? That's non-negative. Hence you can take 0 also. Clear? So 0, 1, 2, 3 can be the values of D. All these values you just plug into your answer and add up all this, because it can be 0 or 1 or 2 or 3. Whenever we have a case of or, it is always addition there. Clear? Right. My next question is, find the number of ways of getting my marks of 3 papers less than 150. So I have written 3 papers and my marks to be less than 150. How do I frame it? My 3 papers, paper 1 marks plus paper 2 marks plus paper 3 marks to be less than 150. Is it less than or equal to? Yeah. Less than or equal to. Less than or equal to 150. So I am considering P1 plus P2 plus P3 is less than or equal to 150. This is my equation, right? Now, until now, we were discussing only with the equalities. Now, this is the first time where we are framing an inequality. How to kill this inequality is what you just have to think, because we know the sum only for equations, right? So if at all we have P1 plus P2 plus P3, if at all we have like this equal to 150, my answer is very simple. My R equal to 150, N equal to 3. I will just apply N plus R minus 1 CR and I'll get my answer. But now this case is different, right? My marks to be less than 150. In such cases, I will include some dummy variable P1 plus P2 plus P3 plus some K, some other paper. Okay, K is what I will include. I will equate it to 150. Now think about it. Am I right or not? If at all K equal to 1, let it be. If K equal to 1. Right? Sum of all this is 150 in the sense, if K equal to 1, tell me sum of all this is how much? 149, right? If K equal to 1, I am getting P1 plus P2 plus P3 is 149. Is it matching with my condition P1 plus P2 plus P3 is less than 150? My 149 is less than 150, right? Matching there. Suppose K equal to some 10, let it be. Right? Then P1 plus P2 plus P3 should be 140 to frame this equation, isn't it? So obviously, P1 plus P2 plus P3 is 140. 140 is less than 150. No problem at all for me. Got the logic there? Suppose K is nothing there here. Nothing. K is 0, let it be. K is 0, right? Even if K is 0, P1 plus P2 plus P3 is equal to 150. My equation is still satisfied. Yes or no? So there is no harm in taking another variable and framing my inequation to an equation. This conversion can be done. Is this clear? Right? Now this is my newly framed question for which I will apply n plus r minus 1 CR. What is R? R is 150, obviously my right hand side. My N is how much? I have 4 papers now. 1, 2, 3, 4. Right? So my N equal to 4. So what's my final answer? N plus R, that is 154 minus 1, that is 153. CR, that is 150. So which is same as writing 153 C3, isn't it? 153 C3, because NCR is NCN minus R. So many times I am using this. So please get habituated to this. Understand? Now going for the next question there. Yes, now this is another combination of the question. That is question number 9. 5 boys and 10 girls sit in a row, they said, such that find the number of ways that between any 2 boys there exists odd number of girls. Okay, we have 5 boys, right? I will arrange boy 1, 2, 3, 4 and 5. So this 5 arrangement of boys is done. Now, how many girls do we have? We have total 10 girls and we need to place number of girls in such a way that there exist odd number of girls in between any 2 boys. Odd number in between boys. Again, 2 alpha plus 1. Odd number of girls in between boys. This is 2 beta plus 1. Here 2 gamma plus 1 and here 2 delta plus 1. So is this the count of girls that I am talking regarding? Right? This is all the count of girls, and when I add all these count of girls, I will be getting 10 because I have 10 girls there. Now I have reframed my question, right? Now this is again add them 2 times alpha plus beta plus gamma plus delta plus 1 plus 1 plus 1 plus 1, that is 4 is 10. So what's your alpha plus beta plus gamma plus delta? That is 10 minus 4, that is 6. 6 upon 2, that is 3. Right? Now apply my multinomial theorem. What is r equal to 3? N equal to 4, right? R equal to 3, N equal to 4. Just apply N plus R minus 1. What is it? N plus R minus 1 CR. So many times I am using this so that you will be remembering that very well. N plus R minus 1 CR. So that is 4 plus 3, 7. 7 minus 1, that is 6 CR, that is 3. Right? 63 value is what you will get it. Right? Now going for the next question. Now my question is x plus y plus z equal to 0 is what they said, where x greater than or equal to minus 5, y greater than or equal to minus 5 and z greater than or equal to minus 5. Right? Now how to reframe my question? They said my x is greater than or equal to minus 5 and it is slightly greater than minus 5. So minus 5 plus something it should be. Right? So I am writing minus 5 plus some a. Right? Plus what about y? Y also greater than or equal to minus 5. So obviously it should be greater than minus 5. Something more than minus 5 in the sense something after that minus 5 you add something to that. So that minus 5 plus b. Again plus what is z? Z is also greater than minus 5. So here also minus 5 plus c equal to 0. Now I have reframed my question, isn't it? A plus B plus C equal to 15. Now all these minus 5, 3 minus 5 go there. Now apply your multinomial theorem n plus r minus 1 CR. Right, isn't it? What is your r? R is 15. N is 3. What is it? N plus 1 CR. That is 15 plus 3. 18 minus 1. That is 17 C. 15. Your final answer is 17C2 will be your answer, right? Good. Go ahead with the next problem. Right, now coming for this problem, a plus b plus c times p plus q plus r plus s equal to 21. So do you find product of two entities is 21? In how many ways this can happen? I'm talking about integral solutions only. How many ways can this happen, right? 21, how can you write it? You can write it like 3 into 7 is 21, or 7 into 3 is 21, or 1 into 21 is 21, or 21 into 1 is 21, right? So how many new set of equations I am framing here, right? So the first one and the second one first deals with a plus b plus c can be your 3. Now p plus q plus r plus s will be your 7, right? The first case, see, I have to calculate case 1, case 2, case 3, case 4 separately, and I have to add all these cases. This is 1, 2, 3 and 4th case. I am talking about case 1 now. So in case 1, a plus b plus c should be 3, p plus q plus r plus s should be 7. Here your r equal to 3, n also equal to 3, n plus 1, n plus r minus 1, CR is what you apply. What is it? N plus R, that is 6. 6 minus 1, that is 5C3 from that case, times. What about here? Your R equal to 7, N equal to 4. So N plus R, 7 plus 4, 11, 11 minus 1, that is 10C7. Right? So you can still write it like 5C2 times 10C3. This is my first case answer. Right? Now talk about my second case. Second case, my a plus b plus c is 7. P plus q plus r plus s is 3. So here my r is 7. N is 3. isn't it? N is 3, R is 7. In this case, N is 4, R is 3. Apply multinomial, right? So N plus R, 7 plus 3, 10. 10 minus 1, that is 9. 9C7 from that case into N plus R, 7. 7 minus 1, 6. 6C3 from this case. That is, you can still write it like 9C2 times 6C3. This is my answer for case 2, right? Now, you will be doing case 3 and case 4. Case 3. Your A plus B plus C will be 1. P plus Q plus R plus S will be how much? 21, right? P plus Q plus R plus S will be 21. Here your N is 3, R is 1. Here N is 4, R is 21, right? Just apply multinomial. N plus R minus 1. 3 plus 1, 4. 4 minus 1, that is 3. So that is your 3C1 from this case times N plus R, 25. 25 minus 1, that is 24C21. You can still write it to be 3C1 times 24C3. Right? That will be your third case answer. Fourth case I am not doing. You just do it and add all these. This is my third case answer. Fourth case is what I think you will be doing it. 1 plus 2 plus 3 plus fourth case answer will be your final answer in the question, right? Now for this case, number of non-negative solutions of x plus y plus z plus w less than or equal to 23. Here also it's the same case what we have done earlier. Do you remember? Converting the inequality to equality. X plus y plus w plus z plus some k is what I am including. I will equate it to 23. Doesn't matter. If k equal to 0, still equal to 23. If k equal to 1, all this sum will be equal to 22, which is less than your 23. No problem at all. Now you apply your n equal to what? 1, 2, 3, 4, 5. R equal to 23. Apply your multinomial n plus r minus 1 CR, right? That is your 12th question. Now 13. Now understand this question. How many integers greater than 100 and less than 10 power 6 have their digital sum to be 5? So if it is greater than 100, it is a 3-digit number, isn't it? Greater than 100, it will be 3-digit number. Perfect. And less than 10 power 6. 10 power 6 has got 7 digits. Less than 10 power 6, it should be a 6-digit number. Understand? Right? So basically, if I take a 6-digit number, I want the numbers from 3-digit number to 6-digit numbers whose sum of all the digits is 5. That means, suppose let me take 1, 2, 3, 4, 5, 6 digits. Like I will consider A, B, C, D, E and F are my digits. If I add all these A plus B plus C plus D plus E plus F, if I add this, I am supposed to get the sum to be equal to 5. They said how many such integers are possible, right? See, my digit A can be 0, isn't it? Then it's a 5-digit number. My B also can be 0. Then it's a 4-digit number, right? So I am getting all the possible count here in this. Suppose till here, if I have 1, 2, 3, 4, 5, this place till here all these are zeros, then I am getting a single digit number which should not be counted for my case. Or till here if it is 0, I am getting a 2-digit number that also not to be counted for my case. Right? So what I am going to do is, I am taking a 6-digit number completely. Later, some 2-digit number is what I will take whose sum equal to 5 and I will subtract that case from this case. Okay now, clear? Because I want all the digits, that is all the numbers which are more than like from 3-digit number to 6-digit number. I don't want any 2-digit numbers into that, or I don't want any single digit number into that, right? Whose sum is 5. I don't want that case. So based on this condition, what I have to do is, I have to take sum of these 6 digits is what I will take equal to 5. Later sum of two digits I will take equal to 5 and I will get the answer from the first case, subtract the answer of the second case from the first case, right? Now, so my n here is how much? 1, 2, 3, 4, 5, 6. Right, n equal to 6, r equal to 5. So applying n plus 1, sorry, n plus r minus 1 c r, right? So apply that. 6 plus 5, 11, 11 minus 1, that is 10. That is 10 CR, that is 5. So what is 10 C5? 10, 9, 8, 7, 6. Reduce it 5 times by 5, 4, 3, 2, 1, right? Yeah, so 4, 3 is 12, but 12, 2 is 24 into 5. Okay, cancellation. 3, 2, 6 get cancelled. With that 6, let it be. 4 ones, 4 twos is what I'm cancelling there, right? 5 ones and 5 twos is what I'm cancelling. I don't know what is the count here. You just do it. Now coming here, a plus b equal to 5. My n equal to 2, r equal to 5. Again, n plus r minus 1. 5 plus 2, that is 7. 7 minus 1, that is 6. So 6c5 is what my answer, 65 or 61 only. You are just going to subtract. 61 is same as writing 6, isn't it? Subtract 6 from this answer, whatever you got. You'll be getting some answer here. Subtract 6 from that. That will be your final answer there, right? So if you're taking 6 digits here, which means all the 3 digit, 4 digit, 5 digit and 2 digit and single digit also will be coming into this case, because 0 is also included in our multinomial theorem there, right? So I can have 0, 0, 0, 0, 0 with some digit 5 here. Possible. But I don't want such cases wherein my numbers are greater than 100 are only taken into consideration. Less than 100 are all. It can either be 2-digit number or a single digit number. Those two cases is what I have to eliminate. And those two cases come from my second case, that is a plus b equal to 5. So from all this, remove that case, you will get your answer there, right? Now, I hope you can reframe the question here. You are given a plus b plus c plus d plus e equal to 22 with all these conditions to be matched there. When a is greater than or equal to minus 3, it should be minus 3 plus some p, isn't it? It is greater than minus 3. Obviously, it should have something else there, right? Plus, the same type is what we have already completed, isn't it? B also to be greater than or equal to minus 1. So, that is minus 1 plus some q, plus c plus d plus c is anyhow greater than or equal to 0, which I am not disturbing that at all, which is equal to 22. Now, p plus q plus c plus d plus e, p plus q plus c plus d plus e equal to 22 here. Now, minus 3 minus 1. How much is minus 3 minus 1? That is your minus 4. Goes there as plus 4. That is your 26. Now, your n is 1, 2, 3, 4, 5. R equal to 26. Apply multinomial theorem. That is 26 plus 5 minus 1. That is 30 C26, which is 30 C4 will be your answer there. Right. Right. So now my next concept is, so the earlier concept was with the multinomial theorem is what we have done, right? So multinomial applications is what we have completed. Almost 14 to 15 questions is what we have solved based on that type. So any problem can be killed using the same formula, n plus 1, n plus r minus 1 CR. Get used with that formula, right? Most important kind. Right, now coming for the number of D arrangements. The next concept is the number of D arrangements. What do you mean by D arrangements? See, suppose if I am having letter 1 and letter 2 and I have to place it into envelope 1 and envelope 2, right? So, what are the possible ways of right choice of placing a right envelope? Suppose if at all L1 has to be placed in E1, it has to be placed there only. So this is one such combination, L1 and L1 to E1, L2 to E2. Both of them I am placing in the right envelopes. That is one such combination, right? Now, if at all I have to take a D arrangement, that's it. Which means what? Which means I am placing my L1 into a wrong envelope, L2 also into a wrong envelope, right? So that means L1 to E2 it goes, L2 to E1 it goes, right? So this is again one such arrangement, right? So suppose when I am talking about D arrangement, I am representing with letter D. D arrangement of two possible things is just one, isn't it? There is only one way of de-arrangement of a mismatch. So this will go there, that will come here. This is just one mismatch which is possible, right? Now you will understand more better regarding if I am giving you letter 1, letter 2 and letter 3 with envelope 1, envelope 2 and envelope 3. Now tell me how many de-arrangements are possible. That means, see, suppose maybe L1 to E2, L2 to E3. So obviously L3 with E1. This is one such arrangement, right? Or what else can I have? Think about. I can give, let me write it separately. L1, L2, L3, E1, E2, E3. I can give L3 to E2, L2 to E1. Hence L1 will be with L3. Here also there is a rearrangement. So this is one way, this is another way. Now, can anyone think about any other way of possibility? Just take a pause and then think about it. Take a pause and think. Think about giving each and every letter in a different envelope, not to the same envelope, right? So I want de-arrangements. De-arrangements in the sense not to the same proper envelope the letter has to go, right? Each and every letter should go to a different envelope only. How many possible such ways are there for me? It is only two there, right? So it is only two, because when I am arranging the three such arrangements, I am getting my answer to be 2, right? So if I am giving 4 such letters and 4 such envelopes, now the things are going to be lengthy for us, right? I cannot keep counting like this. So what should I do? So there is a formula behind it. Most important formula. Please make a note of this formula. Number of D arrangements possible is. Suppose when we are permuting n things. Suppose we are taking n things. That is n factorial into. Let me write it. So n factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. You keep on going that way. Okay. Minus 1 by 5 factorial plus so on until you reach your n factorial. Until you reach n factorial. Okay, na? Right? So let us check whether whatever we have written is right or wrong. I said 3 has got only 2 arrangements. So we are de-arranging 3 letters into 3 different envelopes, right? So obviously according to the formula, if I apply, it is 3 factorial into 1 by 2 factorial minus 1 by 3 factorial. That's it. No, I said go on substituting until you get n factorial. 3 is my letters. So obviously until 3 factorial only I'll be going there. So what's my LCM? 3 factorial. And here, what is the LCM? 2 factorial is 2 and 3 factorial is 6. 6 will be my LCM. 3 minus 1, that is 2 there. 6 and 3 factorial gets cancelled. 2 is my answer, which is my right answer there. Isn't it? Right? So number of such D arrangements, the most beautiful formula is n factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial, keeps on continuing until you get your n factorial there, your n count there. Clear? Right. Now coming for this question, number of ways you put 7 letters into their respective envelopes such that exactly 3 go to into the right envelopes. So this is again a de-arrangement question. They said 3 go to right envelopes. Out of 7, 3 go to right envelopes. Obviously 4 should not go to the right envelope. 4 de-arrangements and 3 right envelopes, isn't it? So now, and I said, so obviously the multiplication of these two cases will be your answer, right? Now, I got any 3 only to be letters to be going into the correct envelopes. So obviously 7C3 are right. Out of 7, I am choosing any 3 and I am sending it to the right places. So that is 7C3 into, what about 4D arrangements? 4D arrangements, again, what is the formula? That is n factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial plus so on, continues until you get your n factorial there, isn't it? Right. Now start. This is 4 factorial. Your n is 4. You want 4D arrangements here. So n is 4, hence it is 4 factorial. 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. That is how you will be going. Stop there because your 4 factorial is done there, right? So now this is anyhow 7C3, that is 7 into 6 into 5 by 3 into 2 into 1 into 4 factorial is 24. Your LCM obviously is 24. Here it is 2, 2 and 12, right? 12 minus 6 here, 6 4 24, 4 plus 1, right? 24 gets cancelled here, 6 gets cancelled here. Your final answer will be 35 times. That will be 12 minus 4, 8, 8 plus 1, 9, right? So 35 into 9, whatever be it, that is your answer for your question, right? So 3 are correct. That means 7C3, 7 out of which 3 are correct. So 7C3. And the remaining 4 will be your wrong envelopes there. So 4 factorial into that arrangement is what you will do there. Now there's another question, like if at all you have 3 boys and 3 girls. You have 3 boys and 3 girls dancing, right? So each and every boy has got a girlfriend. So first boy, first girl, second boy, second girl, third boy, third girl, right? Now the question is like, how many such arrangements are there such that no boy dances with his or her, his girlfriend, right? It's again a D arrangement there. Simply D arrangement there. It's a wife and husband couple. You can select that way. Okay. So this number of D arrangements is nothing but your n equal to 3 is what you take. Apply the formula for 3 factorial into 1 by 2 factorial. It's like 3 factorial into 1 by 2 factorial minus 1 by 3 factorial. That's what your answer is. Clear? Right. So in today's class, we have discussed regarding many questions based on multinomial applications along with the D arrangements, right? So almost all the concepts of permutations and combinations is what we have maximum covered all the syllabus, right? So next we will be bouncing back with more questions from your PACE modules. Then we will be continuing ahead, right? Good luck for your next classes. Bye.